Hello guys, welcome back. I'm Professor Fayaz Kharadi from Department of Mechanical Engineering. In this session, we are going to solve one numerical on epicyclic gear train, which is part 2 from unit number 3 gear train from theory of machine subject. Here in front of you, the problem statement is given. In an epicyclic gear train, the internal wheel A and B and compound wheel C and D rotates independently about axis O. The internal gear A and B, this is internal gear A and internal gear B, and compound gear C and D, compound gear C and D. Now all of you know what is compound gear. The compound gear is which is mounted on same axis of rotation. So speed of NC is equal to speed of ND. So these four gears A, B, C and D mount on same single rotational axis, which is rotate about axis O. The wheel E and F rotate on pins. Wheel E and F rotate on pins fixed to the arm G. This is arm G. Gear A mesh with A and C. Gear E mesh with A and this C, and gear F mesh with B and D. Gear F mesh with this B and this D. Gear F mesh with B and D. All the wheels have the same module and the number of teeth are TC 28, TD 26, TE and TF 18, as these both are compound gear. So teeth on E and teeth on F, teeth on E and teeth on F, which are same diameter. So number of teeth on E and F will be 18 is given. Sketch the arrangement. This sketch is not given. You have to draw the sketch as per the given data in the problem statement, and don't make in this in drawing the figure, because if you don't understand the statement, your figure will be wrong, and if your figure will be wrong, your final answer will be wrong. So a separate marks is given for drawing this sketch in the examination. So you have to first draw the arrangement of gear train. Second, find the number of teeth on A and B, this A and B. Third, if the arm G makes 100 RPM clockwise and A is fixed, find the speed of B. And fourth and last one is, if the arm G makes 100 RPM clockwise and wheel A makes 10 RPM counterclockwise, find the speed of B. Both the time you have to find the speed of B, but input given condition is different. So number of teeth is written here, which is given in the problem statement. So number of teeth on wheel A and B. First of all, we draw this sketch as per data given in the problem statement. This is our first solution. Second, we have to find the number of teeth on A and B. So these are diameters, this circle diameter for all the gears A, B, C, D, E and F respectively. Then from the geometry of figure, I can write down dA is equal to DC plus 2DE. dA is equal to diameter of A is equal to 2 times diameter of E, because E is meshing with A, okay, and E is meshing with C. So diameter of C plus diameter of E here and diameter of E here. So 2 times diameter E. So DC plus 2 times DE is equal to DA. The same is written here. DC plus 2 times DE is equal to DA. And same thing happen for diameter of B also. DB mesh with DF and F mesh with diameter of D. So diameter of D is equal to 2 times of diameter F is equal to dB. This dB. So dB is equal to diameter of D plus 2 times diameter of F. So from the diameter equation, as the number of teeth are proportional to the each circle diameter, so for same module, so therefore this equation I can write down in terms of number of teeth as TA is equal to TC plus 2D TE. So value of TC is given 28, value of TE is given 18. After solving the statement equation, I am getting number of teeth on gear A is equal to 64. And for number of teeth on B, I am writing the statement equation in terms of number of teeth is equal to TB is equal to TD plus 2 times TF. So putting the value of TD and TF, I am getting the number of teeth on gear B is 62. So this is our solution for problem 2. Now third question is asked here. Speed of B when arm G makes 100 rpm clockwise and wheel A is fixed. So for finding the speed, first of all, I make the table in this fashion, in which I am writing the condition of motion. These are the standard condition, and in horizontal row I am writing all the elements of epicyclic gear train in the arrangement. Now, arm G is given, arm A, arm wheel A, wheel B, wheel C and D are compound. So this is mounted on same shaft. So what is the speed of C? Is same as the speed of D. So I am not making two different columns for C and D. I am writing the speed of C and D in a single column. Then small wheel E and small wheel F is also in the arrangement. So I am writing here wheel E and wheel F. Okay, you can make the different column also, or different column by changing the sequence of this wheel A, wheel B, wheel C and D, wheel E and wheel F. Okay, this is up to your choice. So first condition is arm is fixed and give one revolution in counterclockwise direction to wheel A. You can give one revolution to different gear also. It's your choice. But I am solving that numerical by giving one revolution to gear A. Okay. Now arm G is fixed, so velocity of G is 0. I am giving one revolution to wheel A, so this will become 1 plus 1 here as counterclockwise direction, and sign indication for counterclockwise direction is plus. So speed of E, which is machine with wheel A. So what is the speed of E? That is TA upon TE. How? I will show here by simplifying. That you have to simplify in your rough side in examination. NA upon NE. NA upon NE. So NA is plus 1 revolution I am giving. NA. So NA will become driver, and NE, which is meshing with A, this will become driven. So speed of driver upon driven, NA upon NE is equal to TE upon TA. And sign indication will be both form internal pair, so sign will be plus. Both the direction will be same, so sign will be plus. Okay, now taking the reciprocal of this equation, NE upon NA is equal to TA upon TE. Why I am taking the reciprocal? Because I have to find out the speed of NE, so I am taking that NE in numerator side. So NE is equal to TA upon TE into NA. And so NE is equal to TA upon TE. What is speed of A? That I am taking in table plus 1. So I am putting the value of NA is plus 1. So NE will become here TA upon TE. TA upon TE. Now check that TA upon TE, speed of E. Now E is meshing with compound way C and D. So I will find out the speed of compound gear C and D with reference to E. So let us start. Speed of C and D. E is meshing with this outer wheel and this outer wheel will be C. So speed of C is equal to, this will become driver, NE upon NC, NE upon NC is equal to TC upon TE, and this will become minus because these E and this C forms external pair, so direction will be opposite. So minus sign. So taking reciprocal, NC upon NE is equal to minus TE upon TC. So NC is equal to TE upon TC into NE. This will move right side, NE. But what is the speed of NE? NE already we have found out here, NE TA upon TE. So putting the values of NE as TA upon TE, this TE and this TE will get cancelled. So speed of NC is equal to minus TA upon TC, minus TA upon TC. The same value is written here, minus TA upon TC. Now this compound wheel is meshed with F in the figure. So I will find speed of F here with reference to this value. See here, speed of F. Speed of F, we are finding speed of F. Why? Because we have found out speed of C, and whatever the speed of C is same as speed of D, because these C and D are compound gear. So NC is equal to ND. So meshing that D is gear F. So D will become driver and F will become driven. So equation will become as ND upon NF. ND upon NF is equal to TF upon TD, and this is in minus sign because D and F is making external pair. So direction of rotation of both the gears will be opposite. So NF by ND is equal to minus TD by TF. Reciprocal of this because I have to find out NF. So I am taking that NF in numerator. So NF is equal to T minus TD upon TF into ND. So what is the value of ND? This value of ND is equal to NC, and NC we have already found out here. So putting the value of ND as minus TA upon TC, I am getting here minus TD upon TF into minus TA upon TC, minus minus will become plus here. So speed of NF is equal to number of product of dA divided by number of product of number of teeth of FC, dA upon FC, dA upon FC. See here, dA upon FC. The same value I am putting here. Now, with reference to that, I am finding the speed of B. Speed of B. What is the speed of B? See here, speed of B. Don't make mistake in finding the speed. Now we have to find out NB. NB is meshing with F, and we have the speed of F in terms of number of T. So speed of B is equal to, this will become driver and this will become driven. So NF upon NB, NF upon NB is equal to TB upon TF. So taking reciprocal, NB upon NF is equal to TF upon TB. So NB, value of NB is equal to TF upon TB into NF. But what is the value of NF? We have already found out here. NF, TD upon TF into TF upon TC. The same value I will put here instead of NF. NF. So TF upon TB into TD upon TF into TA upon TC. So TF will get cancelled here. So NB will become here product of teeth of DA divided by DC. DA by DC. Product of number of teeth of D and A. So DA upon DC. DA upon DC. Don't make mistake in finding the speed of that values. If these values will wrong, your complete answer will be wrong. Okay. So first row is very important and last row is very important. Okay. Now the second step is give x revolution to all the members. So it will become 0, multiply multiply x to all these elements of our 1. This is 0, this is x, plus x ta by te, minus x ta by tc, this is plus x ta td divided by tc tf. This will become x ta td divided by tc td. Okay. In also in the examination where copying this term, don't make mistake. Now third step, adding y revolution to all the elements. Now the last fourth step is equal to this addition of row 1, row 2 and row 3. The same term is written by taking summation of row 1 and row 2. Y plus x ta by tc, y minus x ta by tc here, and here y plus this whole term, here y plus this whole term. So this is speed of B, this is speed of F, this is speed of compound B of C and D, this is speed of E. Now we have to find out speed of G. That was asked in the examination in problem statement. Speed of B. If arm makes 100 revolution clockwise and wheel A is fixed, we have to find out speed of B. What is speed of B? This final y plus this term. Okay, so y plus this whole term. Okay, now arm G makes 100 revolution clockwise, so y is equal to minus 100. G, what is G? This is y. So y makes minus 100 revolution. And also wheel A is fixed. Wheel A is fixed. So what is the speed of wheel A? X plus y. So x plus y is equal to 0. Y is equal to minus 100 and x plus y is equal to 0. X plus y is equal to 0. So putting the values of y in this equation, minus 100. So x will become 100. So putting we got here value of x and y. So putting the values of x and y here, y is equal to minus 100 and plus x is 100. Putting the values of a, d, c, b, number of teeth of a, d, given here 64 and 26, and number of teeth on c and b is given 28 and 62. Okay, by solving this equation, the number of speed of B we are getting here 4.2 minus 4.2 rpm. So speed is not in minus, this indicates the direction. So speed of B is 4.2 rpm, minus sign indicates clockwise. This is our assumption, 4.2 rpm clockwise. Now last and fourth question is asked here. Find the speed of B when the arm G makes 100 rpm clockwise and wheel A makes 10 rpm counterclockwise. When G makes 100 rpm clockwise, so y will become here minus 100 in fourth row of the table, and wheel A makes 10 rpm. What is the speed of A? A is x plus y. So x plus y become 10 here. X plus y is 10. So putting the value of y in this equation, x is equal to 10 minus 100. This will become plus. So 10 plus 100, x will be getting here plus 110. So putting the values of, we have to find out speed of B. So equation for speed of B is equal to y plus x, number of teeth on A and D divided by number of teeth on C and B. Putting the values of this number of teeth on A, B, C and D, y is equal to minus 100 plus x is equal to 110, and putting the values by solving this equation, we are getting the speed of B is equal to plus 5.4 rpm. That means speed of B is 5.4 rpm plus sign indicator counterclockwise direction. So this is all about speed ratio and how to find out the speed of different gears. So at the end of the session, student can find out the speed of different elements in epicyclic gear train.